All right, so here, question number 22. Let me get my pen. There it is. And my calculator. You need a calculator for these questions. Where did I put it? There it is. All right, let's read it together. 22. Tracy bought a diamond ring, and it was appraised at $1,100. If diamonds have appreciated, that means they've increased in value, at an annual rate of 11%, what is the value of the ring 10 years ago? So, a couple things we need to be aware of. Annual rate means compound interest is once a year. So this is the formula we use for compound interest. We need to be careful about the 1100. 1100 is actually the end amount, and 11 years ago would be the beginning amount. So be careful where the $1,100 goes. So we're trying to find the value of the ring 10 years ago. So it's worth more now. So we want the beginning value. So interest rate, 11%, so it's 0.11 once a year. And then how many years ago? 10 years ago. So that's what I'm going to do. I'm going to divide to get P by itself. So it's 1,100. I'm going to clean this up just a little bit before I put in my calculator, but it's parentheses, 1 plus 0.11 to the exponent 10. All right, here we go. So 1,100 divided by parentheses, 1 plus 0.11 to the exponent 10. And so 10 years ago, the ring was worth $387. Number 23. What annual rate of interest is required to double an investment in 12 years? Annual rate of interest is this formula. The only time you use the other formula, PERT, is if you see continuously, compounded continuously. What do we have so far? So what annual rate of interest required to double an investment in 12 years? Now, we're not given the amount. We just need to take a number and double it. So the easiest number to start with, if you start with 1 and double it, you get 2. It doesn't matter what two numbers you pick as long as they're doubled. So you take a number and double it, and you can use it. The smaller, the easier it is to work with. Interest rate is what I'm looking for. Annual rate means once a year, and then 12 years. So my goal is to solve for R. So let's clean this up a little bit. I get 2. When I go 1 times this parentheses, it doesn't change it. R divided by 1 is R, and then 1 times 12 is to the exponent 12. Now, to solve this is like when we solved radical equations. I need to undo a power. And to undo the power, I do the root that goes with the power. So the root that goes with it is actually the 12th root. Undoes that. So the 12th root undoes the power of 12. So they would cross out. And so what you're left with then is the 12th root of 2 and 1 plus r. To get r by itself, we're going to subtract. So again, we have the 12th root of 2 and subtract 1 on the outside to get r by itself. Let's see how we would actually do that with our calculator. So if I look carefully in my calculator, I don't have a 12th root button. Like I don't have a button to put in the 12th root. So I have to think about it exponentially. So to do that, all radicals can be written as an exponent. The 12th root simply means to the exponent 1/12. 12th, that's what it means. Subtract 1. So that's what I'm actually going to put in my calculator. So 2 to the exponent 1/12. And then once I put it in there as 1/12, I'm going to subtract 1. That's going to give me the answer I'm looking for. So I'm going to move the decimal 2 to the right. And it says to 3 decimal places. So the annual rate of interest, 2 to the right, would be 5 point, and then I'm going to go 946. So 5.946% would be the annual interest rate you would need to double your money in 12 years. All right, what annual rate of interest is required to triple an investment in 8 years? So same start. We're going to Triple means I need to pick two numbers that are tripled, so I'm going to pick the easiest, 1 and 3. You could pick other numbers that are tripled and get the same answer. I'm looking for the interest rate. Annual rate of interest means it's compounded once a year, and time in this case is 8. So let me clean up the equation. 1 times this just leaves me with 1 plus, and r divided by 1 is r. 1 times 8 is 8, and I need to solve this. And to undo the power, I'm going to do the root. Now remember the question before was 12, and it was 12th root. 8, that's going to be the 8th root, undoes that exponent. So the 8th root of 3 undoes the exponent 8. They're inverses. And then we still have 1 plus r. So to get r by itself, we are going to subtract. So inverse of adding 1 is to subtract. I can't put that in my calculator, so 1/8, that exponent, is what I'm going to use in my calculator. So I'm going to go 3 to the exponent 1/8, move the cursor, subtract 1, and then I move the cursor, or move the decimal 2 to the right. So it's 14 point, and then I put down the numbers that follow. So 14.72%, that's a healthy percent you would need to triple your money in 8 years. 25. How long will it take for an investment to double in value if it earns 9.5% compounded continuously? Well, now I have that word compounded continuously. So now I can use the other formula. And when it's compounded continuously, let's see, double in value again. So we're going to start with 1, and then we're going to double it. You can pick any two numbers that double. E is a number in my calculator. The interest rate I'm given, which is 9.5%. So as a decimal, that's 0.095. And what I don't know is t. That's how long it would take. So I'm going to solve for t. So step 1, 1 times e is just going to be e to the 0.95t. To solve an exponential equation, we need to undo it using that logarithm is the inverse. So to write this as a logarithm, the exponent is 0.095t. The logarithm with the base of e is ln, and then what goes inside it is 2. And then to get t by itself, we would divide. So it's ln 2 divided by 0.095. That's what I put in my calculator. So again, ln 2 divided by 0.095, and you get 7.26296. Try it again, 7.296. In this case, it's in years. So that's how long it would take to double your money with that interest rate. 26. Feel free to do it first, of course, and then play the video to see if you did it right, or you can practice with me. How long will it take for an investment to triple? If it earns 4.5% compounded continuously, so that's the indicator. There's the formula. Triple, I'm going to pick two numbers that are triple. Interest rate as a decimal is 0.045. T is what I'm looking for. So 1 times that just leaves me with e to the exponent 0.045t. Write as a logarithm to undo it. So the exponent, the logarithm of the base of e, and then 3 inside, and then the last step is to divide by 0.045. And that's it. That's what I'm putting in my calculator. So it's ln 3 divided by 0.045. So how long would it take? 24.41, I guess I'll round to 4 years. So if you want to triple your money and you get 4.5% interest, it would take 24.5 years to triple your money. 27. How long does it take $1,125 to triple if it is invested at 7% interest compounded quarterly? So compounded quarterly is this formula. So we can use the number that's given, or any two numbers that triple actually will give you the answer, but I'll use the number that's given. You start with 1125 and you triple it, you get 3375 if you triple it. The interest rate is 0.07. Quarterly is 4 times a year, and I'm solving for t. Step 1, I need the exponential by itself, so I'm going to divide. So when I divide these, it's going to equal 3. That's why if you pick any two numbers that triple, when you divide, it's going to equal 3, no matter what numbers you pick in terms of that. We still have 1 plus 0.07 divided by 4 to the exponent 4t. I want to get t by itself, so I'm going to write it exponentially to undo it, or sorry, write it as a logarithm to undo it. So the exponent's 4t. The logarithm is going to have this base. It's a little awkward, 1 plus 0.07 divided by 4, and then inside the logarithm is going to be 3. To get t by itself, you're going to divide by 4. So ultimately, to put this in my calculator, I need to change the base. So it can't be that base. So I'm going to change it to a common logarithm. So I'm going to go log of the what's inside divided by the log of the base. And then I take that answer divided by 4 to get t by itself. So that's what I'm going to put in the calculator. So I'm going to go log 3 divided by log 1 plus 0.07 divided by 4. And then whatever answer that is, I divide it by 4, and I get 15.8, and it says round what to the nearest tenth, so 15.8 works. So it's going to take 15.8 years to triple your money with 7% interest. All right, number 28. How long does it take to double 1,700 if it's invested at 5% compounded monthly? So write this down. Compounded monthly is the compound interest formula. You could pick any two numbers that double, but I'll stick with 1,700. If you double it, it's 3,400. The interest rate is 5%. Compounded monthly means 12 times a year. And then we're looking for t. We don't know how long that will take. So step 1 is to isolate the exponential part. So in front is 1,700. It's multiplying. So I'm going to divide. When I divide it, it's going to equal 2 because they're doubled. To get t by itself, we're going to write it as a logarithm. So the exponent is 12t. The logarithm has this base, 1 plus 0.05 divided by 12. And inside the logarithm is 2. Now, to write that in our calculator, we're going to have to change the base. So it's the log of what's inside divided by the log of the base. That changes the base to a common logarithm, so I can use my calculator. And then to get t by itself, I have to divide 12 at the end. So that's what I'm going to put in my calculator. So again, I'm going to go log 2 divided by log 1 plus 0.05 divided by 12. Close it, and then that answer I'm going to divide by 12. So how many years would it take? 13.9 years to double your money at that interest rate. All right, turn the page. A couple more money questions, and then there'll be science questions, and then I'll change it to a new video for the science questions. So I think it's Jillian, has $10,000 to invest in a mutual fund. The average annual rate of return for past 5 years was 12.25%. So the word annual means compounded once a year. Assuming this rate, determine how long it will take for her investment to double. All right, so we know it's this formula for annual compounded interest. If you start with 10,000 and you double it, it's now 20,000. The interest rate as a decimal is 0.1225. Annual means 1 time a year. And we're looking for t. We're thinking how long it would take. So step 1 is to isolate the exponential part to solve it. So we're going to divide by 10,000. So 20,000 divided by 10,000, it's 2. That means double. We have 1 plus 0.1225 divided by 1, which is just 1225. And then 1 times t is t. So to get t by itself, we write it as a logarithm. So the exponent t, and then we write down log, and the base of the log is going to be 1 plus this. That's just 1.225. Oh, I forgot a 1 there. 1 plus that is 1.1225 if you add them together. And if you divide by 1, it stays the same. And then inside you have 2. So my calculator, I'm going to go log of what's inside divided by the log of the base, which is 1.1225, and that will give me the answer. So if I round it, you can see that's pretty close to 6 years. So how long would it take for that investment to double? And the answer is 6 years. All right, so I'm going to do a different video for number 30 and on. Those have to do with growth and decay in nature and things like that, not financial questions. So that's the end of the financial questions. I'm so grateful that you practiced all the way to question number 29. All right. Mr. GMath, over now.